So, here we are. The first project for School of Sisyphus is already done. I can't believe it's already been more than a month since the first video detailing this project was put out. In a sense, I thought that it would be a longer process than a month, but in some senses it still feels like it was quite a lot of climbing to get through. But I'm really glad that I did the project again, even though it's not necessarily the direction that I see myself moving in from here on out. It was a very good first sort of clear the cobwebs kind of thing, which was great. The importance of seeing it through became very clear. Every project that I had previously undertaken and then abandoned without completing it first, it sort of becomes associated with an abandoned or failed project in memory. And that automatically also affects the confidence that you have going into the next project. And it kind of becomes a self-fulfilling prophecy, the small voice in your head that says, no, you won't finish this, you'll move on to something else within a week. Just grows louder and louder because that ends up being true every time. More directly, the skills that could have been learned in these projects are lost. So there's a lot of skills that you could have picked up had you seen the project through properly the first time that would stand to still be useful in projects, other projects moving forward. But now you have to learn these fundamentals again from scratch when you start with another project that has the same kind of prerequisites as this. So it's very important to overcome the inevitable feelings of distraction or boredom when you're taking on a project like this, at least for long enough for you to be able to see it through to a minimally viable output. So the at least functional iteration of the project, not necessarily one that looks pretty, but the fundamentals, the mechanisms needed were hashed out and figured out and created. Seeing a project through allows these new sets of skills to germinate, and it also allows these skills to be practiced. And the carryover of these skills becomes the building blocks of subsequent bigger skills that will, serve you everywhere else. Whichever direction I go from here, it's all going to involve the same programming language of which I got to learn the fundamentals in a really powerful way. I got to see them practically working, the different data types and the way functions interact with each other. Things like functions were sort of hit and miss for me. It's like if I could find a tutorial that had that exact function that I'm trying to build, then I'd be on board with it. That's like lucky, okay, I can implement that. But if it's slightly different and I have to tweak it for my own use, you find that you don't even have the basics down well enough to be able to do that. So what is it that you've really learned there? The importance of struggling with it and having to dig. Last year I tried to accomplish this by finding tutorials. Well, I first tried to find tutorials that were exactly this project, tutorials that did exactly what I needed this project to achieve. And so I found slightly more basic versions of it, and I found versions of it that had only some of the functions I was looking for, but I spent an inordinate amount of time trying to find one tutorial that I could just follow that thing letter for letter with the least amount of innovation needed from my side. And not only did that waste a lot of time, but it also showed me that I couldn't find the exact project that I was looking for. So all of that initial time would have been better spent learning the fundamentals so that I could build these building blocks for myself. But instead, I was making use of, or trying to find ready-made perfect building blocks from other people and trying to jam those together into one coherent project. And that was sort of a very hit and miss process. Like the only code that you wrote would be the ordering and the glue that makes these pre-existing functions work together. But because you didn't write that initial function, you don't have a full understanding of how it works, why it works the way it does, and what prerequisites elsewhere in your code need to work before that function itself can be executed. And this is not the only problem with this, is that yes, it's difficult to get a project to work that way, but you can come towards some kind of functional version of the project, but then whatever knowledge you'd haphazardly picked up that way in the process is lost within a month or two. When I had to restart this project now a month ago, it felt like doing it for the first time again. What little fundamental Python I had picked up while doing it last year had not been retained. So there was so much of it that had to be almost done from scratch in order to understand it again. So this time around, my initial approach felt a lot slower than the first time I did this. It took a lot more time to find myself getting traction. That was because I was spending a lot of time on the prerequisites and on the fundamentals, learning the smaller building blocks that have to go together to form the functions that eventually all have to go together to form the desired end result. So this took a lot of time because I was reading the docs and the manuals for every library and every operation, every data type that I was working with. I wanted to properly understand how each of these pieces work so that I wasn't spending my time trying to find perfectly built pieces. I was spending my time learning how to build the perfect pieces for myself. Again, the overlap and the carryover of these skills, the fundamentals of Python, things like classes and functions and certain data types, is something you're going to use on many different kinds of projects. It's not something that's only applicable to this narrow application that we're working with now. So it's two very different learning curves. This is knowledge over time. The first learning curve looks something like an aggressive growth. Takes not a lot of time to get going and to get traction, to feel like you're doing things because you found some functions that already work, so now you have some working code. Not that you could explain what it does, but so you have it until there, and then you sort of start to plateau, because then either you've gotten it all to work with existing functions, or you now have to add something in to make it work, and you don't understand how it works well enough to add that in, right? Now the second time around, again, you're slow to start because every piece of prerequisite knowledge needs to be learned from scratch, so it seems in the beginning like this. But all of a sudden, the learning itself goes a lot quicker once the fundamentals are grasped. So once you've got the fundamental building blocks, you start to abstract out the commonalities and you start to see patterns. So rather than understanding this particular function and how it works in this particular application, I understand how this function would work and slot into many different kinds of applications. And that way you start to see those patterns and you learn a lot more quickly, because we are pattern recognition machines after all. And also this way a lot more of that knowledge is retained, because you understand the fundamental mechanisms by which these things work. You understand the logic behind why they work. You're able to apply them and use them in your own ways. You've learned this in your own words. You're able to carry this knowledge across and repeat it, rather than just retain like a parrot, but not actually fundamentally understand or grasp the concepts that you've learned. Similarly to mathematics, it's a very long chain of events when it comes to computer science. There's a lot of prerequisites that you sort of need to understand to get to the next bit. And without these prerequisites in place, the next bit doesn't make a lot of sense. So a subject like history has these different pockets where I don't need to know a lot about World War I to necessarily understand the state of the US economy in the 21st century. Maybe I do, I don't know anything about the US economy in the 21st century. Point being, those aren't necessarily directly related subjects where the one is a prerequisite to learn the other. Whereas in computer science and mathematics, a lot of the time the fundamentals are needed to be ingrained, because they form the building blocks of the bigger and more difficult and abstract concepts as you move forward. So really, the more time you spend on the fundamentals, the more favors you're doing for yourself and for your learning in the long run. Because I worked with SQL Alchemy, Flask, Flask Restless, and Marshmallow, all of these libraries aim to achieve something very different. They have very different functions, but they all have similarities, such as creating classes and then defining instances of those classes within functions, so that you have objects to work with in specific types of data, be it for the SQL Alchemy database or be it for the interface of my web application. All of these very different functions are achieved by the same underlying principle. And understanding that principle now, I can hit the ground running a lot faster with many other libraries. The SQL Alchemy took quite a while to get to grips with when I just started with it. After having spent a lot of time on the SQL Alchemy, I found that picking up Flask and Flask Restless and Marshmallow went a lot quicker than it would have otherwise. Not necessarily because not because these libraries work the same, but because those commonalities could already have been extracted out. I've spent enough time working with the classes in SQL Alchemy to sort of understand how the classes would need to be structured within Flask, Flask Restless, and Marshmallow. So again, that initial slow uptake as the fundamentals are learned, but if that foundation is solid, then you find that the curve really picks up after that, and there's not a lot of drop-off when it comes to the retention. It's not just a catchy thing to say that we want you to learn things the hard way. I'm seeing for myself firsthand how learning things the hard way aids you in the long run. Where I might have been able to find a couple of different tutorials that would help me through this project, I'd likely have come out the other end of the project not knowing much more about the Raspberry Pi or Python or APIs or GPIO or Flask web applications or anything like that, had I not taken the time this time around, where instead I was spending a lot of time poring over the docs and trying to which problems these libraries aim to solve before trying to use them. Understanding what the tool is for completely before using it, rather than just using the tool because you saw somebody else use it without really explaining why. So I hope that these kinds of tutorials are valuable because they show you certain ways to do things, and they impart a sense of what I've learned. But I hope that more importantly you'd still let learning from first principles be a part of your learning process. To not only rely on tutorials, but to get to a point where you sit and struggle with things in the docs, you sit and struggle with things without following a tutorial, but trying to build something from scratch, because that way it's trying to apply your creative problem solving using tools that you've not spent a lot of time working with really lets you come to grips with understanding those tools on a much more fundamental level, and that only serves you moving forward. So I look forward to taking on a couple of more abstract concepts with Python and mathematics for the next while. I'm still finding my feet and relearning a lot of the fundamental prerequisites for that, and I hope that you stay tuned for what comes next. Until then, to keep learning things the hard way. Seriously, you won't regret it.